Prove that root 5 is irrational. So here we need to solve this by using contradiction proof. So first step, let us assume root 5 is rational number. So then consider, see, if it is rational number, we can write in the form of p by q. So consider root 5 equals, here I'll take a by b, where a and b are co-primes and b is not equal to 0. So what are co-primes? So co-primes are nothing but numbers whose HCF is 1. Numbers whose HCF is 1. For example, take 8 and you can take 21. See, 8 is not a prime, 21 is also not a prime. So 8 prime factors are like 2 into 2 into 2 and 21 is 3 into 7. So if you'll observe, the HCF is 1. So what I want to say is, if you write in the form of p by q, you cannot cancel it. You cannot cancel it or you cannot simplify it further. So co-primes are nothing but numbers whose HCF is 1. So here I consider a and b are co-primes. So I'll do squaring on both sides. Next step, simplify. Squaring on both the sides. So root 5 whole square equals a by b whole square. So square and root cancel, 5 equals a square by b square. So 5b square equals a square. 5b square equals a square. So here, so it's very clear that 5 divides, see, 5 divides a square. So 5 divides a square. So I can write 5 divides a. 5 divides a. If 5 divides a, so the remainder will be like 0. Let the quotient be 6. So I'll take, let us consider a equals 5c, because according to division rule, dividend equals divisor into quotient plus remainder. So a equals 5c. So a equals 5c. Again, like squaring on both sides. Again squaring on both the sides. Squaring on both sides. So a square equals 5c whole square. So a square equals 5c whole square. Yeah, so here you will get like a square equals 25c square. So if we substitute this a square value here, so you'll get, see, 5b square equals 25c square. So if we'll cancel this, 5 times 1, 5 times 5. So b square equals 5c square. B square equals 5c square. So here 5 divides b square. 5 divides b square. 5 divides, if 5 divides b square, then definitely 5 divides b. So here both, see, I consider a and b as co-primes, but here I am getting 5 as a common factor for both a and b. So both a and b have the common factor 5. So I consider A and B as co-primes. Co-primes means like HCF should be like 1. But here I am getting common factor as 5. So this contradicts the fact that A and B are co-primes. So I assumed co-primes, but I'm getting wrong answer. So this contradiction, the contradiction arises by assuming root 5 is rational. I assume root 5 as rational number. So this contradiction arises. Hence, root 5 is irrational. Hence root 5 is irrational number. So in this way we need to simplify this.